Hello and welcome to the Unit 3, Section 2 video on angles formed by parallel lines and transversals. So in the first part of this section, we're going to talk about corresponding angles postulate. So if we have two parallel lines cut by a transversal, as you see here and here, we know they're parallel because we have the little tick marks here. Well, we can say that the transversal cuts through and creates corresponding angles, and the corresponding angles that are created are congruent. Now, what do we mean by corresponding angles? Well, we're looking for angles that are in the same slot. So angle 1 is in the same slot as angle 5. Angle 2 is in the same slot as angle 6. So we've got upper left, upper left, upper right, lower left, lower left, lower right, lower right. So we can say that angle 1 is congruent to angle 5. Angle 2 is congruent to angle 6. Angle 3 is congruent to angle 7. And angle 4 is congruent to angle 8. Okay, so with that information, let's take a look at an example. We want to find the measure of angle ABC. Well, here is angle ABC right here, it's x. Well, the corresponding angle is 80 degrees. So we know that x equals 80. So therefore, the measure of angle ABC also has to be 80 degrees. So they're congruent. This top angle is congruent to this top angle because these two lines are parallel. In example 2, we want to find the measure of DEF. So DEF is this angle right here. Well, we know that these two are in the same slot, so that means they're congruent, which means we can set them equal to one another. So 2x minus 45 equals x plus 30. Okay. Now that we have that, we just solve. We subtract x from each side, and so we get x minus 45 equals 30. Oops, got a little ahead of myself there. X minus 45 equals 30. And then we add 45 to each side. And we get that x equals 75. Now we need to find the measure of DEF. So the measure of angle DEF is going to be x plus 30. Well, we know that 75 is x. So it's really 75 plus 30. And so 75 plus 30 gives us 105 degrees. Now, there are a few other theorems that I want to bring up. Now, we have the alternate interior angles theorem. If two parallel lines are cut by a transversal, then each pair of alternate interior angles is congruent. If two parallel lines are cut by a transversal, then each pair of alternate exterior angles is congruent. That's the alternate exterior angles theorem. So basically, if you have alternate interior or alternate exterior angles, those two angles are congruent to each other. They are the same. Now, the consecutive interior angles theorem is a little bit different. If you have consecutive interior angles, then they are supplementary, which means they add to give you 180 degrees. Similarly, it's not listed here, but if you have consecutive exterior angles, they are also supplementary and will add to 180 degrees. So let's take our figure here and let's talk about which angles are alternate interior angles. Well, alternate interior angles would be 3 and 6 and 4 and 5. So 3 is congruent to 6, and 4 is congruent to 5. Alternate exterior angles, you have 1 and 8, 2 and 7. So angle 1 is congruent to angle 8, and angle 2 is congruent to angle 7. And then for consecutive interior angles, you have 3 and 5, and 4 and 6. So the measure of angle 3 plus the measure of angle 5 is going to be 180 degrees. Similarly, the measure of angle 4 plus the measure of angle 6 is also going to give you 180 degrees. So now, in example 3, let's take a look and see if we can find the missing angles. We are told that the measure of angle 8 is 23 degrees. So I'm going to write that right here. So let's start with angles that are nearby. Okay, let's start with angle 6. Well, we know angle 6 is also going to be 23 degrees, and we know that because vertical angles are congruent. Okay, now let's see where else we can go. Well, we could go to angle 4. We know that angle 4 is going to be 23 degrees because angle 6 is 23 degrees and we have alternate interior angles. So we use the alternate interior angles theorem. Okay, now let's take a look at angle 5. Well, we know that angle 4 is 23 degrees. We know that angle 6 is 23 degrees. So we know angle 4 and angle 5 are consecutive interior angles. And since they're consecutive interior angles, they must add to be 180 degrees. So let's use the consecutive interior angle theorem. And do 180 minus 23, which gives us 157. So that's the angle measure here. Well, we can certainly use that to find angle 1, because angle 1 should be the same as angle 5, because consecutive angles are congruent, or corresponding, I should say. Corresponding angles are congruent. So we have angle 1 is 157 degrees because corresponding angles postulate. All right, so now let's see where else we can go. Well, we can go from 5 to 3 because we have alternate interior angles. And alternate interior angles are congruent. So angle 3 is also 157 degrees because of the alternate interior angles theorem. All right, well, we know that angle 2 is still also 23 degrees because it corresponds to angle 6. So angle 2 is 23 degrees thanks to the corresponding angles theorem, or I should say corresponding angles postulate. This one's a postulate, not a theorem. And then finally, we can correspond 157 down to angle 7 from angle 3. And again, here we're utilizing the corresponding angles postulate. So what do you notice about all the acute angles? Well, all the acute angles are 23 degrees. What about all the obtuse angles? Well, they're all 157 degrees. So what we can find out here is if we have two parallel lines cut by a transversal, then all the obtuse angles are going to be the same and all the acute angles are going to be the same measure. All right, now let's look at example 4. We're going to name the relationship between the equations and find the value for x. So what we have here are alternate interior angles. Alternate interior angles. And because we have alternate interior angles, they are going to be congruent. So 9x plus 2 is going to be equal to 119. So we subtract 2 from each side, and we divide by 9, and you're going to get x equals 13. Now in example 5, we have consecutive interior angles. Okay, so that means that they have to add to give us 180 degrees because they are supplementary. So we're going to combine our like terms. Minus 8 plus 104 gives us positive 96. We subtract 96 from each side, and we get 84 on the right-hand side, and then we divide by 12, and that gives us x equals 7. For example 6, we're going to name the relationship between the equations and find the value of x again. Here we have alternate exterior angles. So if we have alternate exterior angles, we're going to set them equal to one another. So let's subtract 5x from each side. That gives us 3x on this side. Let's add 71 to each side, so that gives us 78 on this side. Divide by 3, x equals 26. And in example 7, we have the same slot, upper right, so these are corresponding angles. And because they're corresponding, we can set them equal to one another. Subtract 4x from each side, that gives us 3x here. Add 61 to each side, that gives us 54 here. Divide by 3, and we get x equals 18. In example 8, we're told that A and B are parallel, and we're going to solve for x. In this case, we have this angle and this angle. If you were to put them on top of one another, they would be the same as this angle, just facing the other way. So what we can do is we can just add the other two angles, and we get x equals 70. Now in example 9, we are tasked with finding the value of x, y, and z. This one may not be as clear to see, so I'm going to add a couple of lines here. So I have expanded all the lines here now, and you may be able to pick out the parallel lines here. These are the two parallel lines, the one going here and the one going here, okay, as indicated by these hash marks. Now, what we're going to do is look at the transversals. There's two transversals here, one here, and we have another transversal through those parallel lines, which is going here. So let's start off by finding x. Well, x is right here, okay? Let's use this as our transversal, okay? Ignore this line for a moment. Let's just look at the one going horizontal as our transversal. Well, we have an angle right here, okay? We also have an angle right here. These two angles are corresponding, so therefore they're congruent. So if we have those two corresponding congruent angles, we can say because of the corresponding angles, we can say that x equals 45, because this x angle corresponds with this 45-degree angle. Now let's look at y. We're going to use this as our transversal. Okay? So we have a y degrees here, and we have a 60 degrees here. And these are alternate interior angles. So due to alternate interior angles, we can say that y is 60 degrees. Now, to find z, it's going to take a little bit more work. Z is here. So let's use supplementary angles, because z, 60, and x all together should equal 180 degrees. So this is going to be done with supplementary angles. So we have x plus 60 plus z equals 180. Well, we know what x is. It's 45. So I'm going to plug that in. And then we combine like terms. And we subtract the 105 from each side. And we get that z is 75 degrees. For the last example, let's find x first. Okay, we have consecutive interior angles. So because we have consecutive interior angles, we can set those two angles, the sum of those two angles, equal to 180 degrees. You subtract the 126 from each side, you get 6x equals 54, and divide by 6, and you get x equals 9. Now that we have that, we know that for the y, 126 and y plus 75 are corresponding angles. And since they're corresponding angles, we can set them equal to each other. And so subtract 75 from each side, and you get y equals 51. Okay, so that does it for section 2. Now that we know a little bit about the various theorems and the postulate that we've learned in this section, we're going to flip it in the next section and talk about how we can prove lines are parallel.